silent mode.
Mm-hmm.
Okay, we're live.
All right. Good morning, everybody, and welcome to another incredible episode of SETI Live, which is not happening live at the SETI Institute because, like most every place else on the planet, the SETI Institute is not open at this moment, but the work of the SETI Institute goes on. We're operating in virtual mode like all of you everywhere, but we're delighted to be with you again this morning. So I wish you good morning from here in California. It might be good afternoon or good evening or happy wee hours, wherever you might be. And tell us where you're watching from. We love to hear from you because it's always amazing to us how far around the globe these SETI Live events reach. And we've got a fun topic today, and you're going to meet some incredible people. So just by little way of introduction, my name is Bill Diamond. I'm the CEO of the SETI Institute in Mountain View, California. I'm not in Mountain View, neither is anybody else who works at the Institute at the moment, but that's where we're based. And we are talking today about a program that we've been working on over the last 5 years at the SETI Institute called the Frontier Development Lab, or FDL. And FDL is a partnership with NASA and private industry to bring AI and machine learning tools and techniques to space science and research challenges, primarily research and science priorities for NASA, but also covering lots of different domains, including astronaut health and space medicine and earth science areas where our partnership expands. And we'll go into some of the expanding partner elements of the program separately. But we're going to be talking today to a couple of key partners of the FDL program. And so I'll introduce those. But again, let us know where you're watching from, and we'll be trying to shout out to those of you who are far and wide. We will, over the course of this conversation, have an opportunity for you to ask questions. So if you have a question, put it in the chat. We'll be monitoring the chat, and as we're able to address your questions, we'll do so. But without further ado, I'm going to introduce our amazing guests today. And I'm going to start with a friend and colleague and the director of the FDL program, James Parr, who's joining us from the United Kingdom today. And James, why don't you first of all say hello to the audience, and where you are, where you work, what the hell you're doing, and how the hell you became a space geek and got into this this amazing business. James?
Thanks, Bill, and really excited to be here. And I'm actually in London at the moment, and as Bill said, I am the director of the Frontier Development Lab, which is a wonderful dream come true, synthesis of all the stuff I love. Basically, I grew up loving space and computers, and I couldn't really tell which one was going to be the most fun to do. So I actually started my career doing more computing stuff. And but the question was, how did I become a space geek? And I think there's two answers. The first answer is probably I really loved the $6 Million Man when I was a kid, and he was an astronaut, and of course everybody wanted to be an astronaut, and everybody wanted to be Steve Austin. And I still kind of hear the kind of noise in my head when I start running, which isn't that frequent these days, I have to be honest. But actually I became a product designer, and the reason I became a product designer is because I love all of the engineering that was required to get humans in space. That was really my aspiration. And so when NASA came along and we had the chance to build the FDL with the SETI Institute, of course it was just a dream come true, because all these things as a kid I got to actually do for real.
Awesome. Well, and the FDL program has really been a transformative opportunity for the Institute to really get into the world of AI and machine learning, and see how powerful these tools and techniques are, and how much of advanced data analytics and capability they bring to space science and space exploration. So the opportunity for using these tools to enhance discovery and understanding to speed processes, to lower costs. I mean, it's extraordinary. And over the 5 years of the program, we've done projects in astrobiology, astronaut health, space resources, heliophysics and space weather, earth science. What have I missed, James?
Planetary defense.
Planetary defense. Yeah.
Yeah.
So it's truly been an extraordinary ride. And I want to now introduce you to a gentleman who is also representing a key partner for the program over almost since its inception. And Massimo Mascaro is with Google Cloud, and you might have gathered that he had something to do with Google based on the awesome background he has behind you, because Google is going into space with the FDL program. So Massey, say hello and say where you are physically and what you're up to at Google and how you got into this space geek business.
Thanks so much, Bill, and nice to be here for everyone. It's really exciting. So I'm a technical director in Google Cloud. I particularly work on applied AI. I'm based in sunny San Diego. That is not so sunny at the moment, but actually it's actually my home base, although actually kind of I travel a lot when I can. That is not in the last few months, as you can imagine. How did I get in space? Actually, kind of my background, I'm actually kind of really started actually since I was a kid. I was kind of doing astrophotography and astronomy, kind of going up mountains with telescope. I was that kind of kid. So I got into physics, and that actually still the love of my life. I love science, physics, and astronomy. While I was doing physics, at a certain point, I got fulgurated by the idea of intelligence and the idea of like artificial intelligence. So I started studying that theory, and that led me into a career in machine learning, and then in AI. Then kind of that led me to Google. But my passion is still very high. So about 3.5 years ago, we met actually James and you, Bill, and we kind of got exposed to this amazing FDL program. And we really thought actually that Google and Google Cloud in particular could make a difference there, because we know very well that in order to do science, in order to do AI in science, computation is a very, very important part, and kind of artificial intelligence techniques and hardware is also crucial. So we decided to partner with FDL, and that has been like kind of a journey that now actually is 3 years going and very strong. And I'm super kind of proud that kind of we're able to kind of do this partnership and help actually with these amazing challenges and improvement in science. So that's a little bit about me.
That's awesome. Well, I will say, you know, as you know, Massey, and of course, as James knows quite well, I mean, the FDL program wouldn't be what it is without Google's help, because the massive compute resources, the cloud compute resources, storage, of course, subject matter experts like none other than the Pavarotti of AI and ML have really been transformative for us. And, you know, James had informed me, I guess some time ago, about the difference in compute resources now, or last year, I guess, from when the program started. So just between year 4 and year 1, I think the compute was something like 700 times more compute power last year than in year 1. And I'm sure this year is even more. And this compute power, these compute resources have been really provided by Google. So, you know, we're so grateful, and you know, the program, NASA Science, the Institute Science have been transformed as a result. I mean, one of the things that this kind of compute resource enables to the teams is the ability to do fast iterations of massive compute cycles, you know, and like try something and it doesn't work, so you try it again. Well, if you have to wait 2 weeks for a result, that's not going to work. But if you can take and speed that up, so you're only waiting hours or minutes for things that used to take weeks or months, you know, that's pretty transformative. So in any case, that's awesome. And I now want to introduce Kelly Dorkson from Planet. It used to be called Planet Labs, everybody, but this, so it's like Prince, the artist formerly known as Prince. And this is the Planet formerly known as Planet Labs, now Planet. But Kelsey and Planet are new partners for the FDL program this year, and again, providing extraordinary and amazing resources to us. So I'm going to let Kelsey introduce herself and what she's doing at Planet. Tell us a little bit about what Planet does and how we're leveraging what your company does for the FDL program this year, and then how you got into this space geek business. So Kelsey.
Thanks, Bill, and thanks so much for having me. So yeah, my name is Kelsey Dirksen. I'm actually from Canada, so I do see someone in the chat is from British Columbia, so hi. I'm from Ontario, but I'm based out of San Francisco now, working at Planet as a space systems engineer. Specifically, I'm on the satellite operations team, so I operate our Dove constellation. So what Planet is we're an Earth observation company, and we operate the largest Earth observation satellite constellation in the world. So we've built over 300 satellites, and we've successfully deployed 366, and that's about 10 times of any competitor out there. And essentially what we do is we image the entire Earth every single day, and we use that imagery to help life on Earth using space data. And this is what really got me interested in to be a part of Planet. I've always been super interested in being involved in space. I always wanted to be an astronaut growing up. I still want to be an astronaut for sure. Chris Hadfield is a major inspiration. I know he's quite famous.
Satellite driver.
I know, now I'm a satellite driver. It's hard to choose. This is kind of what actually got me into machine learning as well. Was I as a grad student, I had no idea what to do for my thesis, and I ended up kind of falling into machine learning for space weather, actually, to detect coronal mass ejections, which are these huge solar storms, and how those affect satellites orbiting our planet. And I kind of fell into machine learning that way, and I found out about the Frontier Development Lab while still a graduate student, and I thought about applying as a future PhD student. But when I found out about a Planet, about what they were doing, it honestly just really spoke to me, being able to use space to help life on Earth. That's something I'm really passionate about, because I love space so much, but I really want to have that impact in my daily life, and knowing that I'm doing something that's actively helping humanity. And that's why I joined Planet. And I actually emailed the Planet team before my first day and said, hey, this new program that I haven't heard before, the FDL, they're looking for challenges and partners, and maybe Planet could be a partner. And so I ended up connecting with our VP Analytics, Giovanni Marchisio, and met with him before I even started my first day at Planet, and kind of it went from there. And now we're a partner. So we're providing satellite imagery to the Waters of the United States team, and they're using that imagery for drought detection. So I'm really happy to have kind of initiated that partnership, and I hope that continues for future FDLs as well.
We do too, and it's awesome to have access to the resources that Planet brings to the table and the imagery. And I think still people probably have, really in general, I also have no idea how many satellites are up in space. Of course, now we know that over 300 of them are from Planet, but all of these companies, whether it's for navigation or weather forecasting or research, communications, whatever, just thousands upon thousands. So it's pretty amazing. But and as you know, or I think that in terms of your previous background and interest in space weather, we do have an FDL team this year working again on the sun's behavior and things like coronal mass ejections and the potential that they have for disrupting technology assets here. But so anyway, it's wonderful to have you with us and have Planet on board as a partner. I didn't, I guess, get into my own reason for my own space geek background, but my background is also in physics. I started, I think it was 150 years ago or something like that, studying physics, but getting very much involved in lasers. I think, like Massey said, when you study physics, astronomy is one of those topics that is part of a physics curriculum. And like many people who study physics, I always consider myself a wannabe astronomer, but probably was never quite smart enough to be an astronomer. So I stuck with lasers, which have served me well. And most of my work was in lasers for telecommunications, in fact, fiber optics, which is essentially the hardwired infrastructure that makes the internet possible. But 5 years ago, I had the opportunity to come and take the helm at the SETI Institute, which is absolutely the coolest job I've ever had. It's too bad I had to wait to be so old to get it, but no turning back. It's so wonderful to be here. Just a few shout outs to some of the folks who are watching us from all over the place. And then James, I'm going to turn it over to you to have a little conversation. But we have people watching from Prague in the Czech Republic and France. I'm not sure exactly where, Adelaide in Australia, Venezuela. We have Texas, we have Edinburgh in Scotland. We have British Columbia. Somebody's watching us from Venus, which that's a good trick. Monaco, and let's see, Pretoria in South Africa, and Lahore in Pakistan, Cape Town, South Africa, Monterey, Mexico, Oklahoma City, Georgia in the US, Germany, So India, Sweden, and Australia are also popping up. So anyway, wonderful greetings to all of you. Thank you so much for joining us. And again, please don't hesitate to tell us where you're watching from. Somebody's on I-95, so that's pretty cool. I know I-95 only too well on the East Coast. Scary place to be. And somebody asked, should we expect all the FDL systems to use sound effects from the $6 Million Man? So James, you might address that later. Can we use ML to detect anomalous signals in space? The short answer to that is yes, but we'll come back to it.
Yeah.
We got Portland, Oregon, and others in England. So James, you've got some company watching you, Cleveland, Ohio, et cetera. So James, let me turn it over to you and start talking a little bit more in detail about the program and what our guests are doing with us this year.
Well, should we start with this anomalous signals one?
Sure.
Because we've just published some results on this, and it was to do with looking for anomalous signals on the moon. But of course, these aren't radio signals. We're looking for minerals, and so the team essentially used a very, very clever combination of layering data sets. But what they were able to do was look for thermal anomalies. So essentially, this is as the shadow of the moon, or the terminator goes across the surface of the moon. Of course, anything that's metal cools down a little bit slower. And so they were able to see this effect and essentially do a map of the lunar surface. And we now have a full lunar globe of where all the minerals are, potentially metals. These are obviously from surface deposits, so deposits from meteors and comets. So that was using machine learning to mine that data. And that work's just been published. And of course, we're really thrilled with the team and the hard work they put into making that happen. And Massey, I know we've used a lot of Google technology on that. I don't know if you wanted to talk about that for a moment.
Yeah, I mean, like one thing actually kind of that I love a lot about that project is that on one side, it's one of those projects where you don't have a lot of examples of label data. What in machine learning we call label data. This is basically kind of example where you know what the ground truth is. We don't know actually where, for example, in this case, metal or water actually is on the moon. But on the other side, actually, you can be clever and you can actually detect, as you said, kind of in this case, thermal anomalies, but in general, kind of patterns that are not really kind of very easy explainable from the rest of the data that you have on the moon. And this actually is a set of novel techniques that the team has used in this. Some of those are pretty kind of state of the art, and we have actually kind of examples at Google in text understanding and speech of using the same techniques. And the team actually was able to transpose those techniques to the problem of, detecting useful things on the moon, and actually kind of extracting actually this kind of information. Now, the other part that actually I'm very excited about that project is the fact that, of course, like the moon is big. And in order to do this project, you have to have very, very kind of sophisticated imagery that likely actually a lot of like satellites that are orbiting the moon actually are providing. But the amount of data behind this is just kind of astounding. And so like the big need is then actually to be able not just to kind of develop a smart method, but develop a smart method that can scale to literally kind of planet-sized objects. And this is really actually where kind of Google kind of has been kind of doing a lot of its work. It's not just about making something smart, it's about making something smart and scalable at the same time. And the team has done a tremendous job. And I think actually this is really kind of one of those projects that really kind of goes to the heart of what Google does. And so like we were very excited actually to work with them.
Yeah. So speaking of planet-sized projects, one of the reasons we were excited having both of you join today was looking at application of machine learning to the Earth. And we have a number of projects this year. One is the Earth Intelligence Engine. Another is this knowledge discovery framework coming from NASA Marshall. And then we also have the digital twin project. So we're all, a number of projects where we're sort of feeling our way into this vision of the idea that we could start monitoring the planet or using machine learning and high-temporal Earth observation technology to really manage our planet in a way we haven't been able to before. And I really wanted to open this up, or perhaps tease out the opportunity, because it seems like there are two revolutions happening simultaneously. One's this ability to observe our planet from space with constellations of satellites, as opposed to one sort of bus-sized object that needs to be, tasked to do the job, versus having a constellation which is able to see these, to provide a much higher rate of coverage. And then at the other end of the spectrum, we have, what Google provides with its cloud infrastructure. But I sort of wanted to perhaps change the conversation to Kelsey and say, from your perspective from Planet, like, how do you think about the sort of revolution that's happening, and how would you describe this, and what gets you the most excited about what's possible?
Definitely. I think it really is just the cadence that we're able to provide this imagery at, where, like you mentioned, instead of relying on a single satellite to take an image, and maybe you're looking at data from months ago to try to analyze change, because Planet has 1,300 images across the planet every single day for the past few years, we're able to see and make actionable change, because we're able to see changes every single day at a certain spot on the planet, depending on where you're looking. So, for example, we're now working with the FDL Australia team to help them assess the bushfires that happened earlier this year. And it's because we have that daily imagery that they're able to really assess how these fires are growing, do different fuel assessment, machine learning techniques on it as well. So I think it's the ability to have this change every single day. You're able to see a new picture rather than relying on pictures that are much, much older. It just opens so many opportunities to see change in many different ways. And this is not only for forest fires, but for things like drought detection or agriculture, or even, looking at ships that are not supposed to be where they currently are, things like that. I mean, the possibilities are really endless now that we have this almost like a flip book, when you have a bunch of pictures, and when you flip the flip book, you can see the change. It looks like it's moving. It's similar to that as well. And that's really what gets me excited. It's also really cool that I get to see all these images as a spacecraft operator. I mean, the one behind me is the Canadian Arctic, and the changes happening in the Arctic right now. We just released images, I think yesterday or the day before, of the last Arctic shelf breaking, and that's something we were able to detect because we have rapid revisit at these places every single day. We have images there, so it's really, really interesting, the different changes we can see all across our planet.
It's interesting. One of my last flights before we all went into lockdown was coming back from Europe and then flying over Greenland. And I've got pictures that I took that are not dissimilar from what you're showing there, where, I was noticing in coastal areas of Greenland, that you could see flowing water and rivers and land, which I'd never seen before, and flyover. So, to have access to that kind of, that's my own observations separated by many years, but to have this data set of, images every single day over several years all over the planet. I mean, it's extraordinary how informative that can be. And we have a team this year that's actually trying to produce projected satellite imagery. In other words, they're using AI tools and ground truth based on existing satellite imagery, and then weather forecasts and other things to try and imagine what this satellite image would look like, in 5 or 10 years or 20 years, to help inform, what changes are coming and what maybe we might do to prepare for them or prevent them. So it's what an extraordinary set of data that you have access to for us.
It's interesting because you hear about this concept that astronauts have, which is called the orbital perspective. And this is the view of the Earth they get because they get to see it every 90 minutes. Like, do spacecraft drivers have that as well? Are you finding that your perception's changing a little bit?
I would say a little bit for sure. The images that we get to see are obviously unreleased before they go through our processing pipeline and things like that. So some of the images I get to see on a daily basis, it doesn't even look like Earth. It looks like it could be another planet, almost science fiction. And it makes you feel very small because you're seeing these images on such a large scale, and it's really amazing. It kind of brings me back to the reason why I wanted to join Planet, was to make an impact on Earth using kind of space data. And it's because we have these daily images that we're able to make this like visible, accessible, actionable change. So yeah, I think I probably not as much as the astronauts do on the International Space Station, but definitely a little bit of that perspective for sure. I mean, the planet is just so beautiful, and especially now because we are on lockdown and we've been this way for many months. We're not able to travel. I also love traveling, but I'm able to at least scratch that itch a little bit with the planet imagery at the very least.
You need a flotation tank, so when you're to complete the feeling of being in space.
We have, James, a question for Kelsey that relates to what she was just saying. That is, what kind of tools or techniques or AI ML resources does Planet use to perceive what are, some rapid changes in some of the images you see, in terms of things changing more rapidly than we might expect on some of these Earth locations?
Definitely. I mean, I think one that's fairly intuitive is just because you're comparing a picture from one day to the next and almost creating a GIF that way. We've done that with the Beirut explosion. Actually, most recently, we've have these pictures side by side we shared on Twitter that can show really the damage that was done on this explosion just by showing images side by side. We also have with our Planet Analytics, we're using machine learning to identify specific objects in our data, like vessels or aircraft on the ground or roads, buildings, tree covers, things like that. And we're trying to progress from tracking changes to identifying these kind of broad scale trends to help users plan for the future. So we're trying to provide users analytical tools so they can do the machine learning almost quote unquote themselves, so that the average customer can use it as opposed to someone that needs this really extensive background in machine learning. It'll be almost intuitive tools that users can use to see those changes. So we've shared quite a few kind of seeing the aircrafts because the airline industry is of course suffering majorly right now with the lack of travel going on. So it's interesting to see airports with all of their aircraft basically parked. And we're trying to work on analytics for being able to identify things like that for users to use.
Yeah. Awesome.
So that's a perfect segue. Thank you, whoever put that question up to talk about the other revolution, which was, AI, but also cloud infrastructure. And Massey, I wanted to sort of give the mic to you and talk about. I think everybody's aware of the power of machine learning for science, but people might not be aware of the utility of a cloud infrastructure to actually deliver on that. And I thought it'd be useful for us to talk a little bit more about that and hear how Google's thinking about this.
Yeah, so I mean, first of all, around kind of the need of machine learning and AI, I think actually kind of there's relatively little debate today, but just kind of piggyback on what Kelsey actually just mentioned. I think actually the problem is that we have so much data. Take actually, for example, satellite images. There is a deluge of it. And in a sense, actually kind of, it's impossible for people to kind of look at every single spot. Now, if you know that in Beirut actually something happened, you will kind of look very carefully at that. But actually the power sometimes is actually by looking at all the planet at once, for those little details that actually then sum up. And that's actually where I think actually machine learning can kind of help. And this actually is really an analogy of a lot of other things where you can actually do the same idea. You have actually massive data and you're basically trying to find the needle in the haystack and actually then correlate it over time and over space. So in order to do that, you need actually kind of typically like two things. One is that you need a lot of examples. This is what we mentioned before around labeled data. And this is actually also to kind of piggyback on this, actually kind of to also put actually another kind of pin on the board around the fact that it's still very important to have humans in the loop. We're not kind of trying to kind of build AI to as in a sense kind of substitute human, but actually to make humans become super powerful, to make humans actually kind of extend their abilities to massive scales. And so if you can have people, let's say, kind of identify important things in a relatively small set of, let's say, for example, satellite images, then you can use ML to then scale that to the entire planet over time, 30 times a second, right? And that actually is the big power that ML actually, I think, actually can really provide, at least in the short term. Then actually kind of to your question about compute, in a sense, actually what you're trading off is human brain power for silicon brain power. And the problem is that today where we are, our ability to make silicon smart at the same kind of level of both kind of electrical power and size than humans is not very good. We need very big machines and a lot of electricity in order to kind of run something that actually kind of doesn't even kind of pale with respect to what a human would do. But actually, it helps that human. It makes it actually kind of better. So like this actually is where kind of at Google actually we're really kind of trying to kind of move the needle. We're not just trying to kind of build more computers and kind of just kind of amp up our data centers. We're also very much into trying to understand how to do this in a both sustainable way and a way that actually can grow. So as you probably know, like Google Cloud and Google as in general kind of has been carbon neutral for a number of years now. We have invested a lot of money in technologies that make our machine learning use much less power than it would. I think actually I read the statistics that kind of all the data centers of the world actually account for something like 3% of the carbon emission. That is a staggering number if you think about it, because you're comparing with things like agriculture and transportation. But actually that number is going to increase and kind of worsen up as we go. So I think actually that's actually is a very kind of interesting aspect, is how do we make this more sustainable? We definitely will need more and more of this. There are a lot of like studies that show how the compute that is used for machine learning and AI is actually increased 5 times faster than normal compute for kind of our general life that has been increasing, as you know, exponentially for the last 40, 50 years. Well, AI compute is actually increasing much faster than that. And we need to kind of be very, very wary. And of course, like us at Google, the work actually, these things at very, very large scale are kind of on the front line of this. But I think actually it's a discussion that needs to happen actually more in general, how we make this more sustainable. That said, I do believe that this is actually transforming both how we do data processing in general and how we do science in the specific. And it's just going to increase because like the amount of advantage that you get by using those techniques in this area, it's probably something that you cannot walk back. So I think actually the best thing is to make it sustainable, not to try to kind of use it actually too little.
So, Massey, an interesting point you raised. Well, first of all, I had wished that when you talked about not replacing humans, I was able to like just, you know, unzip and reveal the robot underneath. I think that would have been totally cool. But unfortunately, I couldn't do that. Anyway, but, you know, to your point, I mean, just in terms of space research, you know, you talk to officials at NASA and they'll be the first to admit that NASA has more data and generates more data in all of its missions and all of its activities than it's ever had time to actually look at. And there's probably so much science, so much discovery, knowledge, and learning to be gained from data that we haven't yet seen. But having this kind of, you know, AI resource that is, to your point, is improving so rapidly, gives us the prospect and the possibility of going back, you know, let alone trying to keep up with new data, but even going back to data sets from, you know, various space missions that we haven't even looked at yet to see what we can discover. So it's truly extraordinary.
Yeah, and also like, you know, just as a shout out to like a project that I was really fascinated by last year from FDL, not only you can look back at old data, but sometimes you can make the old data better. So a team last year enhanced very old data sets using AI to kind of extract more information out of them. I think actually that actually is also kind of extremely fascinating as a trend.
Yeah, absolutely. That was terrific. James?
Yeah, so I wanted to say to Massey, thank you for bringing that up. Like, you know, I think, you know, when we started saying, you know, could we build a digital twin for Earth or could we build an Earth intelligence engine? It seemed, should we say, disingenuous if it wasn't carbon neutral. So thank you so much for Google being able to, you know, provide that for us. But I think that sort of brings me to the sort of the theme of the discussion. You know, when you hear those ideas like a digital twin for Earth or this sort of vision of you know, where, you know, the combination of geospatial technology like Planet and AI infrastructure like Google, now where does your head go? What do you imagine is possible in the next few years?
So I mean, there are many ways of answering that question. So I'll just kind of pick my kind of personal line of thought. But one thing actually I'm extremely fascinated about is the fact that, in a sense, so far actually a lot of like the AI that has been applied to science is really be about kind of inferring things from data. So in a sense, actually, we use machine learning algorithms that have been developed for things like kind of detecting cats in pictures or recognizing human speech. And actually, we apply to kind of scientific data. I think it's kind of the real kind of next step, and FDL has been at the frontier of this in a number of projects, is really how we make actually kind of science, and of course, like I'm a physicist, I'm going to say physics, but kind of any kind of law that we have discovered very often, actually over hundreds of years of very, very hard work and kind of in ingenuity, into the grain of AI. How do we actually empower AI to know the physics and the law of nature and actually extract better patterns from the data that we give it, instead of just kind of starting from scratch and kind of looking at the data as that could be actually any random data set. So that actually is one big area. And again, as I mentioned, kind of in FDL, there are a number of teams that are working in kind of in doing this, in making this possible. The other aspect that I think actually is very important in science is you're not just content actually with predicting things. You very often want to explain and kind of, again, understand the core structure of things. And that's actually another area where machine learning has not kind of necessarily kind of been super advanced in the past, because it wasn't honestly like the biggest focus, right? I want to kind of recognize people inside Google Photos. I don't necessarily need to explain how I do it or how I came to that conclusion as far as it works. But actually, there are a lot of areas where that's very important. One very notable one is, for example, healthcare. But actually, I think actually in science that will also be important. So that aspect of explainability, I think it's a very important one for science. And it's a very important one actually to have science then actually also help machine learning. We always think about how machine learning can help science, right? But actually, I would love more and more to see scientists come up with new techniques and new ideas to help machine learning also in other areas, like, for example, healthcare or, kind of perceptual ideas. The third thing, the last one actually I'll mention, and then maybe kind of some others can add here. I think actually kind of we're more and more kind of dealing with problems where we have to combine very, very different data sets together. This is something that we humans do very well, right? We're very good at connecting the dots and kind of, if you want, kind of moving information from one domain area to another. Again, traditional machine learning has not been very good at that. In science, it's very, very important. Case in point, again, going back to our satellite images example, people think about satellites very often as just kind of nice pictures from the sky. The reality is that most satellites actually take a lot of pictures across different bands, ultraviolet light, infrared light, of course, visual light. Then they have radar data. And actually, satellites are only one of the sources of data about our Earth that we have. You can have aerial photograph, you can have street view photograph, you can have like local measurement done by people or sensors. And the need to combine this data is more and more becoming the frontier what artificial intelligence needs to do. The biggest example of this you see in things like autonomous vehicles, autonomous cars, they have to do this continuously. But actually more and more you will see actually kind of that AI, at least kind of about our real world, will have actually kind of to confront this problem. And I think, again, science actually is really at the frontier of this particular aspect and can probably kind of contribute back to the machine learning community, not only with like applications, but also with hopefully kind of techniques and theory.
Yeah, I'd love to hear from you, Kelsey. When you hear things like that, like the concepts like data fusion and digital twins and all that sort of stuff, where does your head go? Is that stuff you're thinking about?
Definitely. I mean, it reminds me of the work that the Waters of the United States team is doing right now, combining not only, I don't want to give away too much what they're doing because I know they have their showcase, but combining planet imagery as well as imagery from Maxar and using different data sources to be able to infer one final result with drought detection, especially in the case where your imagery, the resolution might be too small or not good enough. If you have 10-meter resolution, for example, but you're trying to look at something a lot smaller, you might need to use other indicators like vegetation growth around a stream to be able to infer whether or not that stream actually has water in it or not. So yeah, it's definitely very complicated. I think it's a bit of a double-edged sword as well with the black box that some people think machine learning is, where you just feed a data set you find online into a convolutional neural network or CNN, and then you get an output and you're like, yep, this works great. So I really liked what you said about using science to be able to help improve machine learning rather than just trying to extract an answer out of a machine learning data set. I think that's something that's really important too, because machine learning doesn't always have to be used on a data set. I think that's something that's really important to think about as well, is looking at your data set and understanding what your data is showing you and what information you want to extract from it, and whether or not you want to apply machine learning to it, and if that's the best route to do it, or whether or not it'll be a more like purely data science method. I think that's something important to think about as well. But I mean, the possibilities really are endless with machine learning, which is why it's so great, especially working in this area of space. That the data is truly endless at this point. I actually used for my own thesis work data that had been published 2002, and no one had used this data before for this particular method of detecting these coronal mass ejection storms. So there's no lack of possibilities with machine learning, and definitely combining different data sets to find the answers that you're looking for. Is the possibilities are really endless there. So it's a very exciting field to get into, and there's no shortage of machine learning applications. So for those interested as well, I think that's one thing too, for the people that are listening right now that may not have a machine learning background but are interested in getting into it, there is a lot of open source documentation and information online for you to learn a little bit more about it too, if you wanted to get involved, because there's no lack of data for us to apply. Definitely.
That's for sure.
That's one of the things I like about this, when you get the combination of machine learning folks and scientists together. You can look at a problem and say, well, so this seems intractable, and then someone goes, well, what if we look at the growth around a river? This could be useful for us to spot or characterize. And similarly with the thermal anomaly stuff, this detective work required to actually find a breakthrough. And that this is why it's neat for us to have this combination of people who know the problem working with people who know the machine learning, because that's when the magic happens. I'm sort of conscious of the sort of the intention of this conversation, which was to promote our end event, which you mentioned, and thanks Kelsey for mentioning. And on Friday we're going to be showing the results of this work, and this is going to be streaming live, our live AI showcase, and of course everybody watching this today is very welcome to join. And I think we may have put the sign up in the chat, but just so everyone's tracking, this will be at noon Pacific time. So that's 3 o'clock Eastern and 8 o'clock British time. And that'll be streaming directly from this channel, the SETI Live channel, but also FDL.ai. And this will be a showcase of the 2020 work. And so we'll be sharing the results of the Waters of the United States project, which Kelsey mentioned, and going back to the moon. And yeah,
this will be an opportunity. I think there's been some good questions that have been popping up, and I will say that the problem is, if you get people like me and James together with people like Massey and Kelsey, we could do this all day. But you wouldn't be happy with that, and then we'd lose our jobs, because there's other things that we're supposed to do. But some of the questions I've seen pop up here will be addressed when the teams have their live presentation. So what James is talking about on Friday is now not a discussion between us, but rather each of the 8 teams we had this year. These are interdisciplinary teams of AI and machine learning experts together with early career scientists, so domain experts in the particular topic. Each of those 8 teams will be presenting their results to the general public. You're all invited. You're all welcome at fdl.ai. So we hope you'll come along for that. And if you go to that link today, James, is that right, that they can go to that link today and register or sign up? So that
yeah.
So please do that, and share it with your friends. You're going to see some extraordinary work and extraordinary results, enabled and fueled by resources such as Kelsey and Planet and Massey and Google Cloud have provided. I saw somewhere in the chat that our friend and colleague Shashi Jain from Intel, which is another one of our partners and has been working closely with Google Cloud on the FDL program, is watching today. So hello to Shashi. And so yeah, I think Friday's going to be a lot of fun. Tomorrow we have a more formal set of presentations to NASA headquarters staff and NASA stakeholders and other partners. So that's going to be the more technical deep dive. But Friday's general presentation events are going to be great fun, and we're hoping all of you can join us.
And then also we're going to have another one of these tomorrow, and we're going to be, if today was sort of thematically looking down, tomorrow we're going to be looking up, and we're going to be chatting about application of AI and space data to exploration and deep space.
Yeah, that'll be cool. What time is that, James?
That's at 11 a.m. Pacific.
Pacific time. Okay. So yeah, come back tomorrow. I was going to say the same bat time and same bat channel, but it's actually going to be a little bit different, a little later here on the West Coast, but hopefully you'll join us for that. We'd love to see you on Friday. You're going to be amazed at what these young researchers have done. And of course, again, what they've done has been enabled by partners like Google Cloud and Planet, Intel, IBM, Mayo Clinic, US Geological Survey, Luxembourg Space Agency. Who am I leaving out, James?
MIT.
MIT.
Oh, NVIDIA.
This year. So, you know, it really extraordinary research, extraordinary young researchers, extraordinary resources at their disposal, thanks to our partners. And you won't want to miss that. So anything else for us to throw out here, James, before we wrap this up for today?
I think that was the perfect wrap. I think this is. I think we'd lose the moment if we keep on sort of trying to squeeze it out. So I think
we're better not prattle on, as we say. But well, I want to thank you, Kelsey, very much for joining us, and for Massey for joining us and joining us again, and of course your colleague Scott as well. It's been such an amazing ride these last 5 years. And just as a reminder to everybody that's out there with respect to this year's program in particular, you know, FDL has always been a program where the researchers have come together physically at the SETI Institute in Mountain View, being housed at NASA Ames Research Center, and they work together, they spend time together day and night over this intense 8-week period, and they get extraordinary results. This year, we couldn't do that. So this year, not only did the teams have their normal challenges, but they had to do all the work virtually. And we're talking about researchers from all over the world working together on platforms like this and in a virtual environment, never having physically met one another, and yet working together diligently. And again, interdisciplinary skills, different backgrounds, different cultures and languages and time zones. And yet all of the work that's happened this year has been done in this virtual environment. So it's been a social science experiment as well as a research science experiment, and clearly only enabled by virtue of the kinds of tools we have at our disposal, thankfully, in this day and age. So that's something really special about this year's FDL program. And we've learned a tremendous amount. And I kind of hate to say, I hope we never have to do this again. I hope we never have to do this again by virtue of having a pandemic that is gripping the planet. But we may be doing combinations of virtual and in-person types of events in the future because of the productivity we've seen out of the teams this year. So please join us on Friday. Join us tomorrow again for another SETI Live discussion about the program. And join us Friday if you can, to hear directly from these teams and the extraordinary work they've done. And you'll also meet more of our amazing partners. So for Massey and Kelsey and then James, I'll turn it over to you before we say goodbye. But thanks.
I was going to say we also forgot to say thanks to the team at Lockheed, of course, who's supporting 2 of our challenges, but also NASA as well. And of course, we couldn't do it without them.
Yeah, absolutely. All right. Well, thanks again, everybody, for your time this morning. Thank you to our audience from all over the planet. Speaking of planet, and thanks for joining us. We hope to see you back tomorrow at 11 a.m. Pacific time for another SETI Live discussion on the FDL program, looking up, as James says, and hopefully we'll see you Friday for the team readouts. With that, I'll say goodbye from the SETI Institute. Thanks very much on behalf of our friend Massey at Google and Kelsey at Planet and James over there in the UK, managing the FDL program. Take care, everybody. Stay safe, be well, and we'll see you soon.
Bye, everybody.
Bye, everyone.